Dear students, in the previous class I have explained how to use PERT for scheduling. In this class, I am going to explain how to do the risk analysis with the simulation for scheduling purpose. So, this was just to know the continuity I brought this slide. So, in the previous class we are discussing about PERT. In this class I am going to discuss about risk analysis with the simulation for scheduling. So, the agenda for this lecture is what are the uncertainty in the projects, how that uncertainty can be minimized. Then I will discuss about risk analysis for managing uncertainty. So, one of the way to manage the uncertainty is risk. So, that risk analysis I am going to use a software an add-in in Excel called Crystal Ball. So, I have taken two examples. One, I will explain how to predict the net present value. The second one, I will explain how to do the PERT using Crystal Ball, that is risk analysis using simulation. So, what are the uncertainty in the project? So, life with the project is characterized by uncertainty. There are so many uncertainties there in the project. For example, the time required to carry out an activity is uncertain event. The cost and availability of resource is another example of uncertain event. The success of a research experiment is uncertain event, and the wishes of the client also uncertain, because they may keep on ask different requirement. The actions of the competitor is another example of uncertain event, ups and downs of interest rate, and apart from that the most uncertain is the random moods of a senior manager. These are typical of the things that can upset most carefully planned and managed projects. While it is possible through careful pre-planning to reduce somewhat the degree of uncertainty surrounding by any project, uncertainty can never be eliminated, but we can however manage the uncertainty so as to reduce the impact of the ambiguity existing in our uncertain world. So, we have discussed so many uncertainties that cannot be completely eliminated, but the impact of that uncertainty can be minimized. One method for managing uncertainty is to perform risk analysis on the data involved in our managerial decisions. This risk analysis requires us to make assumption about the probability distribution of variables and parameters affecting our decision. So, when we do the risk analysis, we have to assume certain probability distribution of our variables. So, these assumptions allow us to adopt Monte Carlo simulation model and evaluate the impact of given managerial decisions. In the previous lecture also, before that I have discussed how to use Excel for doing Monte Carlo simulation, but in this lecture I am going to do Monte Carlo simulation using an Excel add-in called Crystal Ball. When compared to Excel, this Crystal Ball have more options to choose different types of input which follow different distributions. Many times the risk analysis is done mathematically. So, individual values of each variables in the model are selected at random from the probability distributions we specified, and the outcome of the model is calculated. So, what will happen, any simulation model, there will be different input, say x1, x2, assume that this y1 is output. So, the x1 may follow certain distribution, x2 may follow some distributions, that has to be assumed. It may be follow normal distribution, it may follow uniform distribution. So, the software what that does, it takes randomly different values based on its distribution for x1 and x2, and it does the calculation by using some mathematical model and finally provide the output. So, this process is repeated many times, and the model's output for each repetition is used to construct a statistical distribution of all the outcomes. So, there will be x1, x2, there will be set of values for each and every value of x and x2, there will be different y1. So, the output of that y1 is distributed in the picture form. Based on that output distribution, then we can have some managerial inferences. This distribution shows the risk profile of the decision. So, whatever the output comes, the output if you plot in the form of distribution, we can get so many inferences. So, that is called our risk profile. So, the risk profile is considered along with the parent organization strategies and policies and the wishes of the client and many other factors when making the decisions. Now, we will take an example of prediction of net present value. This is an hypothetical example. The example says a large producer of decorative ceramic pots is considering installing a new marketing software package that will, it is hoped, allow more accurate sales information concerning the inventory, sales and deliveries of its pots and its vases designed to hold artificial flowers. Now, let us assume that the expenditure of that project, purchasing a new software in this example, are fixed by the contract with outside vendors, because that may be the maintenance of the software. So, what will happen, that there is no uncertainty about the outflow, but there is a of course uncertainty about the inflows. Assume that the estimated inflows are shown in the table, I will show you in the next slide, and include most likely estimate, a minimum estimate and maximum, and that maximum estimate is called optimism. There are three types of estimate: most likely estimate, minimum estimate and maximum estimate. Look at this figure. This is the hypothetical example. Say the hurdle rate is given, inflation rate is given. Many times the inflows, see there are up to 2020x9. This column shows the inflows, this column shows the outflows, this is the net flows. That is the difference between inflow minus outflow. See, this star represents at the beginning of 0th year. So, the investment is $125,000 because there is no inflow, there is no income from the project, that is the buying the software. In the first year the investment is $100,000, that time also there is no inflow, not the first year, the beginning, the end of the 0th year. Then first year it is $90,000, similarly third year $15,000, like that there is various outflows, and we are getting the benefit out of this project only from here onwards, that is the x2 onwards, 50,000, 120,000 and so on. Now, what will happen, these portions we are going to consider an uncertain inflows. Obviously, in practical you cannot exactly predict what is going to be inflow, but these outflows are fixed because this was the requirement of the contractors. Anyhow, we have to pay for that, and the hurdle rate is fixed, but we are going to consider the inflation rate is one of the uncertain cells. So, what is the setup for this problem is, we are going to consider inflows in the form of uncertain. So, there are 3 time estimate is given. For example, year 2, so the minimum inflow is $35,000, most likely inflow is $50,000 and maximum inflow is $60,000. So, what we are doing, we are replacing this $50,000 instead of a single value, we are supplying 3 values: minimum, most likely and maximum. Similarly, we are replacing 120,000, then we are going to provide minimum, most likely and maximum. So, there are 2 uncertain input, one is the inflow, other one is inflation rate. So, the firm fixes the hurdle rate of return. So, the only remaining variable is inflation rate included in finding the discount factor. We have assumed that a 2% rate with a normal distribution plus or minus 1% as the variation, a tolerance we can say. So, the inflation rate follow normal distribution, the mean is 2%, the variation is plus or minus 1%. This is the one input. It is important to remember that other approaches in which only the most likely estimate of each variable is used are equivalent to an assumption of certainty. What we can do, instead of having 3 time estimate like minimum, maximum and most likely, but sometime some people may consider the most likely value as an approximate. So, the major benefit of simulation is that it allows all possible values for each variable to be considered, instead of keeping it as a constant value, like considering only the most likely value. So, we can have all type of possibilities of the estimate, that is the advantage of this simulation. So, using crystal ball to run a Monte Carlo simulation requires us to define 2 type of cell in the Excel spreadsheet. So, 2 important things has to be declared when we use crystal ball. The cells that contain uncertain variables or parameters are defined as assumption cells. The next one is uncertain variables. The example of uncertain variable is here is, so the cell B8 to B15 here, this portion we are going to say is uncertain variables. The cells that contain outcome of the interest in the model are called forecast cells, that is D17. And another uncertain cell is this inflation rate. So, each forecast cell typically contains a formula that is dependent on one or more of the assumption cells, because that forecast cell should have some formula, because that should be dependent on our assumption cells. Simulation may have many assumptions and forecast cells, but they must have at least one of each. Now, we will go to crystal ball. I will explain how to use crystal ball for predicting the net present value. Dear students, I have installed the crystal ball in my computer. After installing, there is a tab appearing crystal ball. When I click here, I have already entered the data here: hurdle rate, inflation rate, inflow, outflow and net flow. Net flow is the difference between inflow minus outflow. Now, I am going to define all variable cells, uncertain cells. The first one is inflation rate. You click here, then go to define assumptions. So, you have to choose what distribution that inflation rate follows. So, you can go distribution gallery. When you click gallery, there are so many distributions there. Suppose if we go all, you can get, there is a normal, triangular, uniform, log normal. It is up to you to decide based on the problem what distribution that uncertain variable is following. So, now now I am going to assume that inflation rate follow normal distribution. So, I am going to choose normal. Yeah, this is normal. So, when I enter normal, it is asking mean, that I have to enter, because 0.02 is the mean, and the tolerance for that inflation rate is, the variability is 1%. If it is 1%, it will follow 3 sigma limit in a normal distribution. So, 1% upon 3 is 0.0033. So, that I have entered as a input. Now, I am going to choose this B8. Here, as I told, it is going to follow beta distribution. So, define assumptions, you go to distribution gallery. See, here there is a distribution called beta PERT. So, I am going to click this one. When I press OK, it is asking minimum value, likeliest value and maximum value. So, once you enter OK, so as soon as you define the distribution, the color will change to green. So, here already I have defined minimum, maximum and most likely value for the uncertain cells. Similarly, for this cell also, B9, B10, B11, for example, B11, if you go here, already defined it. So, minimum is 88. It is based on from this table. For example, X5, X5 is minimum 88, most likely 105,000 and the maximum is 116,000. So, this value already I have entered it. The next I have find the net flow, that is inflow minus outflow. Then here I have used NPV formula. So, what is the NPV formula? The beginning of the year the investment is 125,000. So, D5 plus the end of the 0th year my investment is, in the NPV formula I have to define what is the interest rate. So, interest rate is B1 plus B2, hurdle rate plus inflation rate, comma, then I have to choose the net flow, that is D6 to, from this to D6 to D15. So, that is the formula for NPV. So, after getting that I am getting 113,875 at present, the value is coming in the negative. So, now I have fed all the value. The next what I have to do is I have to define what is the forecast cell. So, click here, then define forecast. Here I have to say name of that cell, I say NPV, then unit, what unit, say assume that it is dollars, then you press OK. Now, when you start this, our simulation starts. Our simulation is completed. Look at this picture here. This one. Now, the mean NPV value is $17,179.85. Median is 17,126.25. Standard deviation is 8,013. Variance is given, skewness is given. So, now what we are predicting out of this simulation is, so the NPV value for this problem is 17,179. Here one thing what you can do, suppose if you want to know 95% confidence level, what will be the mean predicted NPV value. So, here it is certain, so you change to 90. So, when you change 90, so this area, that is 6,000 to 30,000, that is our range of predicted NPV value. So, this certainty says based on level of certainty you can choose what is the predicted NPV value. So, this is the way to simulate a problem using crystal ball. And if you want to know more options about the output, go to view, you can check frequency, cumulative frequency, you can check percentile and so on. Then you can click, there are many tab references there, go to chart, then you can say what are the other things which you want from the chart, that also can be done. I have explained how to use crystal ball for doing the simulation, and there this is the list of various distributions that can be considered for our uncertain cells. It can be normal, triangular, uniform, log normal and so on. Here we use the normal distribution for the inflation, and for the inflows we use this beta PERT distribution. This is another input for the inflation. We have chosen as inflation follow normal distribution, mean this one, standard deviation is 0.003. You should remember that if it is a 1% in a normal distribution, 1% represents 99 will cover 99.7% of the normal distribution. That is indirectly representing the 3 standard deviation. That is why we are dividing 2% plus or minus 1%. So, instead of this 1%, we are writing only standard deviation here. How it is 1% upon 3. So, that will be the 0. Equal to 0.0033. The next input which I have given to predict the NPV was beta distribution. That also explained. I have what is the minimum value, what is the likeliest value and the maximum value. This was our output. So, what is the inference from this output is we are getting the mean NPV value as 17,815 with certainty of 100%. You can change this certainty level and we can see what is the corresponding chances of probability of getting that NPV value. Suppose if I want to know 95% chance, what is the 95% confidence level, what will be the range of my NPV, then we can say that it may become like this. So, this will be the lower limit, this will be the upper limit. Now, we will go to another example of using crystal ball for using risk analysis. So, this problem is a PERT problem. So, what is given is here the activities are given, optimistic time is given, most likely time is given, pessimistic time is given, and what are the immediate predecessors are given. So, the analytical approach to finding the duration of the critical path network as well as the path times for the network's other path is based on the assumption of beta distribution. Now, that same assumptions we are going to follow, that the different activity times is going to follow beta distribution. Using that assumptions, we are going to find out what is the total completion time for the project. The figure shows a model for simulating the project completion time. It is surprisingly simple of what seems to be a such complex problem. You might have seen previously, if it is a beta distribution, we have used mean formula for converting 3 time estimate into single time estimate, but here it is very simple. So, after entering all the values in crystal ball, we can label the columns. So, the first one for each activity. So, we have activity A to J, we are going to write all activities and then we are going to enter all the possible path and finally, we are going to find out the total completion time for completing all this activity. So, what I have done for the given table, for example, there is a various activities are given, activity A, B, C, D, E, F, G, H, I, J, and optimistic time is there, most likely time, pessimistic time, and the immediate predecessor of that activity is also given. So, by considering this predecessor, I have drawn a network. So, what are the possible path here? We can go A, D, I is one path, then B, E, I is another path, then B, G, I is another path, then C, E, I is on one path, then C, I is one path, then C, G, I is another path, then C, H, I, like that all possible paths we can find out. So, that path also has to be entered as a input. So, the most difficult job one faces is identifying all possible paths to be evaluated. For small network, for example, what I are showing for illustration purpose, this is not difficult, but for large network identifying all possible path may be difficult. So, instead of using crystal ball, you can go for some other software for that. So, this is the input for our simulation. When you look at this input, you see activity A, B, C, D, E, F, G, H, I, J, up to that I have written. Then I have written all possible path A, D, J, B, E, J, B, F, B, G, I, C, E, J, C, F, C, G, I, C, H, I. So, here the bottom I have entered the, because for example, activity A we are going to have 3 time estimate that we are going to enter. Activity B also, because all 3 time estimates are same, we are going to use as a constant, then only C, D, E, F, and for G also we need not specify the probability distribution because all the 3 values are same. Then what you have to do, we have to find out the path duration. How we got this value is, you have to define a formula. So, you have to add the duration of activity A, activity D and activity J. Similarly, here you have to add the duration of activity B, E, J. Then, so for this all the path we have to find out the maximum values of different path, that is going to be our project completion time. So, maximum path is the critical path and corresponding duration is our project completion duration. Now, I am going to use crystal ball to simulate and predict what is the completion time for this PERT network. So, here I have entered all the activities, all the path, and here also I have defined that activity A, it followed beta distribution. So, go to crystal ball, then define assumptions, then choose beta PERT. Here I have entered minimum, likeliest and maximum, then press OK. For second activity, all the values are same, you need not define it. For example, activity C, click this cell, define assumption, go to beta PERT, press OK, then you will get the where this picture. Here you have to enter the minimum value, likeliest, most likeliest value and the maximum value. Like that you have to define for all the activities. Okay. For example, here K3, what I have done, I have added A3 plus D3 and J3, it is summation of all individual activities. For example, BEJ, so added B3 E3 plus J3. Okay. Like that I have entered for all the path, I have used a formula to find out the total duration. Now, the completion time for the whole network, so what you have to do, it is a maximum of K3 plus K3 comma R3. So, we are considering all the path, whichever path is taking longest path, that is going to be by duration. Here only the uncertain cells are all the activities. So, now go to define forecast. So, I have chosen this S3, I define completion time, then press OK, then start the simulation. Yeah. Now, this is the output of our crystal ball. So, the mean completion time is 46.31 and the median is 46.08. This is 86% certainty. Suppose you can change it, you put 100%. Yes. So, when you can enter the certainty level, and another interesting thing is that you can see here the percentile value is given. So, for what the percentile value says, the probability of completing this project less than 61.64 days is 100%. For example, probability of completing this project within 43.45 days, it is a 30%. So, this interpretation can be obtained from the percentile chart. Here I have brought the screenshot of the output. Here it says that the mean completion time is 46.12 and we are also getting this percentile chart. It says that, so 45.84 for completing this project less than 45.84, the chance is 50%, because it is a median value. Okay. So, in this lecture I have discussed about the possible uncertainties in your project. So, that uncertainty can be managed with the help of managing the risk. So, how to manage that risk? I have used a software called Crystal Ball. So, I have taken two problems, one is for NPV prediction, the second one is our PERT problems. So, I have defined how to give the input and how to choose various probability distribution for the input, then how to choose the forecasting cells, then I have run it, then I have shown the output. Thank you.